Hello class, this is lesson 6-5 about graphing inequalities in two variables. So remember that for a linear equation, a point, x comma y, was a solution when we plugged it in and we got a true statement. The same thing goes for linear inequalities. You're going to take a point, you're going to plug it in, and see if the inequality statement is true. So let's go ahead and do some practice right now of plugging a point in. So 2x minus 3y is less than 6. So let's see if these points are solutions. So 2 times 0 minus 3 times 1, is that less than 6? Well, that's 0 minus 3, which is negative 3, and that is less than 6. So yes, that point is a solution. All right, let's plug in 4 comma negative 2. So 2 times 4 minus 3 times negative 2, is that less than 6? That's 8 plus 6. Is that less than 6? I don't think so, because 14 is definitely not less than 6, so this is not a solution. All right, let's plug in 2 comma 2. So 2 times 2 minus 3 times 2, is that less than 6? Well, that's 4 minus 6, which is negative 2, and that is less than 6, so yes, 2 comma 2 is a solution. Final one, let's plug in 3 comma 0. So 2 times 3 minus 3 times 0, is that less than 6? 2 times 3 is 6. Take away 0 is still 6, but that's not less than 6. So no, 3 comma 0 is not a solution. All right, let's go ahead and move on now. We're going to look at how to graph these linear inequalities. And you have had a lot of practice graphing equations, and so you're going to start just like you were graphing a linear equation. Okay, so it's really important that you have it in slope-intercept form, because that's going to be the easiest way for you to graph those today. Once you have it in that form, you're going to start the same exact way. So you're going to plot your y-intercept, and then you're going to move based on your slope, either up or down or left or right. Okay, from there, you're going to draw your line, but it might be a solid line or a dotted line. So if it's less than or greater than, it's going to be a dotted line. And if it's less than or equal to or greater than or equal to, then you will draw a solid line. Last thing is you're going to do some type of shading. And you're going to shade one side of this line. And the way that you're going to determine which side is you're going to pick a test point on one of the sides. I like to pick 0, 0 because it's a very easy point. And you're going to plug it in. And if you get a true statement, then you're going to shade the entire side that has your test point, like 0, 0. But if you get a false statement, then that means 0, 0 is not one of your solutions. You're not going to shade that side. You'll shade the opposite side. So let's practice. Let's graph y is greater than or equal to 2x plus 3. So I'm going to plot 3 on the y-axis and go up 2 and over 1. And since it's greater than or equal to, I'm going to draw a solid line going through my 2 points. And then I'm going to determine what side to shade. So I'm going to pick that test point 0, 0, and let's plug it in. So 0, is that greater than or equal to 2 times 0 plus 3? Well, that's just 3. So 0 is not greater than or equal to 3, so I'm not going to shade the side with 0, 0. I'm going to shade the whole opposite side. All right, let's move on to y is less than or equal to x minus 1. So I start at negative 1, and I go up 1 and over 1. And now I can go ahead and connect those with a solid line. And again, I'm going to pick my test point 0, 0. So let's plug it in. So 0, is that less than or equal to 0 minus 1? Well, that's negative 1, which is not true. So I'm not going to shade the side with 0, 0. I'm going to shade underneath my line instead. And I'm done. All right, now we have x plus 2y is greater than 6. Let's rewrite our equation first. So let's subtract x on both sides. And then we can divide everything by 2. So y is greater than negative 1/2 x plus 3. So let's start at 3, and I'm going to go down 1 into the right 2. And this is going to be a dotted line because it is greater than, not greater than or equal to. And now I can go ahead and pick my test point of 0, 0. And I can go ahead and plug that in. I'm going to plug it into my original inequality. So 0 plus 2 times 0, is that greater than 6? Well, 0 is not greater than 6, so we're not going to shade the side with 0, 0. All of my solutions are going to be shaded above. All right, one more here. I have y is greater than or equal to negative 2x. So again, the y-intercept is just right there at the origin, and I'm going to go down 2 and over 1. This will be a solid line, but because my line goes through 0, 0, I need to pick a different test point. So I'm going to try 1, 1. So is 1 greater than or equal to negative 2 times 1? Yes, it is. So I'm going to shade the side with 1, 1. And so all of those points that I'm shading are solutions for this inequality. Now let's graph x is less than 3. So this is going to be a vertical line, and it's going to be a dotted line crossing the x-axis at 3. And if I plug in 0, 0, there's only an x value to plug in, so it's really easy, 0 less than 3. And that is true, so I'm going to shade everything to the left side of my dotted line. So all of those points that I'm shading are solutions. All right, one more. Y is greater than or equal to negative 2. So this is going to be a vertical line, and it's going to be solid, crossing through negative 2. And if I plug in 0, 0, is 0 greater than or equal to negative 2? Yes, it is. So I'm going to shade everything that is above my line. All right, to wrap this up, I want to show you another way that you can actually graph, and it's way easier. It's kind of a little secret. If you have less than or equal to as your inequality, you're going to shade below. You're going to shade everything that is less than the line, if that makes sense. So if you have the man walking on top of the line, I'm going to shade everything below it. Same with this other one over here. The man would be on top, and I'm going to shade everything below the man. Look at that. So I don't even have to pick a test point. If it's greater than or equal to, you're going to shade above, or everything that's greater than the line. So there's the man. I'm going to shade everything that is like above the mountain, where the man is at. Same with this other one over here on the side. If that's the man sliding down the hill, I'm going to shade everything that's above that hill that includes the man. So to practice that, let's graph 4x minus 3y is less than negative 12. So let's go ahead and rewrite our equation first. So we're going to subtract 4x on both sides. I'm left with negative 3y is less than negative 4x minus 12. Divide everything by negative 3, and that gives me y. And I have 4/3 x plus 4. But if you remember, whenever you multiply or divide both sides of an inequality by a negative, you're going to flip your inequality. Okay, so maybe make note of that right now so that you don't make any errors when you're graphing. Okay, so we have our inequality now. Let's go ahead and graph it. So I'm going to start at 4. And since I can't go up and to the right, I'm going to go down and to the left. And it's going to be a dotted line. And since it says greater than, I'm going to shade everything above my line. I don't even have to pick a test point. And I'm done. So I hope that this lesson made sense to you, but let me know if you have any questions when you come into class.